This one we have to first convert it into the augmented matrix. So again, for augmented matrix, you have your X, your Y, and your Z, and then your number. And you always want to make sure that they are in fact lined up. And you'll notice here that they are lined up very nicely, so everything is good to go there. So we can just write out the coefficients. So we have 1, 2, -1, 1, and then -1, -2, 2, -2. And then 3, 6, -3, and 5. Now, we'll start with row 1, and we'll try to get our leading 1 followed by the zeros below it. So we have the leading 1. Now we focus on getting row 2 to have a 0. So we'll start with row 2 minus, and then our row 1, which is going to just be 1, and if we subtract those, or basically add those two, we'll be good to go. We'll get the 0. So we'll write out row 2, -1, -2, 2, -2, and then we'll be adding that to row 1, 1, 2, -1, and 1. Okay, so if we do that, you get 0, 0, 1, -1, and this is your new row 2. Now, while we're at it, we can look at our row 3. So row 3 also needs to get a 0, and to get that 0, you're going to take row 3 minus 3 times row 1. So you'll have 3, 6, -3, 5, and multiply by 3 the entire row 1. So -3, -6, +3, -3. And then you'll add those two together. So this gives you 0, 0, 0, 2, and this is your new row 3. Now, right there, it is very alarming because of the fact that you have 0, 0, 0, and then a number. That means that there's no solution. You can put this together as one big matrix if you want to, where you have 1, 2, -1, 1, 0, 0, 1, -1, and then row 3, 0, 0, 0, 2. But anytime you have zeros with a number here, that means that there's no solution. So basically you have some sort of like parallel line situation going on.